Hi class, it's Miss Lytle. Welcome to the Redox and Electrochemistry review. As always, you'll see that major understandings are placed throughout the review sheet in bold. Make sure you read these major understandings, and below them, we'll test your understanding with a couple practice multiple choice. As always, the last page of the review sheet has their answers. Feel free to skip ahead. The first question asks us to calculate the oxidation state of nitrogen. To refresh our memory of oxidation state, let's pull up a copy of our periodic table. Zooming in, let's see what we can find out about oxidation states. Here we can see that the oxidation states are provided in the upper right-hand corner of each element box on the periodic table. Nitrogen has a copious amount of oxidation states possible. So how are we going to calculate this? Well, recall that in a compound, the reason in which compounds form is so that the members of the compound can obtain stable, noble gas electron configuration. Noble gases are stable because they have complete octets and a zero selected oxidation state. So what we need to do is set up an equation so that the sum of all the oxidation states for each element in this compound must equal 0. So we have 3 elements. Recall that elements are symbolized by a capital letter. So looking at our formula, we have sodium, nitrogen, and oxygen. Now what we're looking for is the oxidation state of nitrogen. So we'll just place an X here in the upper right-hand corner. Now looking at our periodic table, it's easy to observe that the only oxidation state for oxygen, element number 8, is a -2. So we'll place a -2 here in the corner. And the only oxidation state for sodium, element number 11, is going to be a +1. Now, in addition to having these oxidation states, we have to refer back to our formula and look at the subscripts. Recall that the subscripts tell us how many of each element we have. So sodium has no subscript, so there is a 1 implied here. Now nitrogen also has a 1 implied, and oxygen has a 2. So what we're going to do is we're going to examine these and make sure that the sum of all the oxidation numbers equals 0. So here we're going to look at each set of numbers that I'm boxing, and we're going to multiply them and add them together so that they equal 0. So again, that gets +1 for the oxidation state of sodium times 1 for the number of sodiums plus X, because we're unsure of the oxidation state for nitrogen, times 1 because there's 1 nitrogen plus 2 because there's 2 oxygens times -2, and this all must equal 0. So as we continue to do simple algebra, we see that 1 plus x minus 4 equals 0. In this case, x must equal +3. The next question asks us about oxidation. So we'll have to refer to our definition of oxidation. So here we're going to refer to our kind of funny mnemonic devices, but we remember that in oxidation and reduction, we can remember Leo and Gur. So when we want to figure out what is oxidation, we know that oxidation is going to be the loss of electrons as oxidation, while the gain of electrons is reduction. Now, the reason in which we say that gaining electrons is reduction is because something's reduced. That would be the oxidation number. So if in reduction, the oxidation number goes down, then oxidation, the oxidation number must go up. So let's look at our choices. We're looking for the choice that has an increase in oxidation number. So when we examine all our choices, we see that in choice 1, our oxidation state is increasing. In choice 2, our oxidation state is decreasing. Choice 3, again we have a decrease. And choice 4, again we have a decrease. So by a process of elimination, obviously, choice 1 is our best answer. The next question, again, has us refer to our definition of oxidation reduction. Again, they're referring here to reduction. So remember that a gain of electrons is reduction. So why is a gain called reduction? Because, of course, the oxidation number is being reduced. So our best choice is choice 3. In the question number 4, again, we're asked about reduction. A gain of electrons is reduction. So we're looking for the oxidation number to go down from the reactant side to the product side. Looking at choice 1, the oxidation number, when not given, is always going to be 0. So to go from 0 to positive 1 is an increase. That is not a reduction, so that is not our choice. In choice 2, we go from a 0 to a negative 1. So choice 2 might be our answer. Choice 3, we go from 3 to 0. So again, that might be our answer because that number is going down. Choice 4, we're going from 2 to 3. That is definitely not a reduction. So choice 1 and 4 are eliminated. Now we have to ask, well, is the correct answer choice 2 or choice 3? Well, in chemistry, we recall that everything on the reactant side of equation is gained, and everything on the product side is lost. This is true for energy. This is also true for electrons. So if we're gaining electrons, we want the electrons to be on the reactant side. We also want to make sure that our equations are mathematically correct. So when we look at choice 2 and we look at the oxidation states, what choice 2 says is 0, and the arrow means equals negative 2 because I have 2 negative 1s plus negative 2 because I again have 2 negative 1s. So that means 0 equals negative 4. That statement is definitely not true. So this cannot be our answer. Let's look at why choice 3 is the correct answer. Here, our mathematical expression says gold plus 3 negative electrons equals gold atom 0. And we can see that this is a true mathematical equation. So choice 3 is the best answer. In the last and final question, it asks us how the total number of electrons lost in an oxidized substance compares to the total number of electrons gained in a reduced substance. And we can recall the law of conservation of mass and energy. So in the world, mass and energy cannot be created or destroyed. It's always conserved, meaning that the mass of a reaction when we start is always equal to the mass of a reaction when we complete it. Same goes for energy and electrons. So we must always have an equal number of both gained and lost. Remember, when we look back in choice 4, we assured that that happened because the total charges were the same on both sides. 0 equaled 0.